Hey everyone, this is Hack It Friday meeting where we discuss different ideas that can be built on Near. And I have another idea that I actually didn't build the DEX last Friday, got distracted. Uh, but this Friday, I'll build something else because I'm gonna organize a workshop. And as part of this workshop, there are going to be participants who will write contracts, and I want to make it interactive in some way. So I want to build the application that, first of all, visual, and then people can see their progress. So let me present a whiteboard. I don't know if it's needed. Okay. Cool. So the idea I want to build is somewhat similar to Berry Club, except it's not people who draw, but the contracts that draw. So there's going to be a master contract that contains a drawing history, and then it tracks. Hey, Trevor. Then it tracks contracts that know how to draw. So let's say we have something like a board. And on the right, you may have contracts. So let's call them macro. And this macro is essentially another contract that has some algorithm how to draw at the given coordinates. And how that's gonna work is you can add your own macro. So there are gonna be like add macro field. You enter an account ID of the contract that you want to add, and it runs a basic verification. So it calls like, are you supporting drawing on this board? It should reply like, yes, I am, or something like this. Some secret phrase to verify that it's appropriate contract. And then it's added to the list. Now you can select any macro and activate it. Then it will display kind of like a drawing place where you want to draw. So you like move your mouse and like, let's say, click somewhere here, and that will issue a cross contract call to this macro contract, and then macro contract should call us back with the drawing instructions. So it can pass a bunch of primitives to draw. So for example, a line. So it can maybe draw a house at this place, and it will act like SVG. So it can like fill it with different colors, or write the text on top and stuff like this. So, and then macros are going to be sorted by usage. So the most popular are going to be on top. And so the participants of the workshop, they will have to just fork a macro, which by itself like empty, and then put a bunch of instructions on what to draw, like a bunch of primitives into the draw function. So basically implement a draw function, then deploy this contract, add this macro to the board, and they can draw and that will keep the history of drawing like below, and maybe like display the last 100 or something like this. And you will be able to turn off any of the macro. So that's my idea. What do you think? Is it useful to teach people? Can we convert it later to a tutorial or something like this?
Makes sense to me as an example of cross-contract calls. Pretty easy to understand. I have no idea how complex it would be, but I suppose if it's just a matter of repeating some of the things that are already there, and I wasn't quite sure if there's some sort of command language that you sort of use to make the macro from a factory, or if the macros come pre-built, or you send it a string of coordinates, or what the details are there. I'm not quite sure how far you've thought that way, but it clicked for me in a few seconds. So that's always nice to have an example of something that's easy to understand.
I also want to make it like for people who don't know Rust to be able to actually do something at this workshop, because I assume majority of people don't know Rust when they just like, hey, I want to like build on a blockchain. And having some kind of examples will be enough for you to implement it. So it's more like you clone a template, you build it, and it should work. So you fill, for example, an macro name, some kind of parameters of the size of this drawing, or maybe it just takes a rectangle instead and it draws inside the rectangle. It scales it up. So yeah, the workshop basically to show how Near works. So this is like, it's going to be on testnet, so I don't have to worry about storage as much. And people don't need to worry about their contracts being deployed. So they don't need tokens, real tokens. But at the same time, it should be doable within like an hour. If you already have set up for like Rust, Git, and PM. So you should be able to create a Near wallet on testnet. Then you should log in a command line, install Near CLI, clone a repo, modify the contract, deploy it on a testnet, go to this pre-deployed app, add your macro, and like test it out live.
So macro in this case is like I'm drawing the letter A. I've been like kind of half paying attention. Sorry for the dumb question.
Yes, so something like you can name your macro potentially. So you can say this is like a house macro, and then you draw a house there. But I'm pretty sure I can support more stuff than just a line, rectangle, circle, and stuff like this. I can do text, I can do polygons, and maybe images. I'm not sure if I want to do images and how far I want to do text. It would be cool to have animation, but maybe next time, like add an upgrade that has frames. So you essentially animate your drawing. then like if this is WebGL drawing, then it can be like pretty efficiently animated. Okay, any other questions, comments?
What feedback are you looking for, Eugene? Like whether or not this seems like it would fit in an hour and fit for the audience? Is there, if there's more feedback,
well,
maybe I would ask for more detail.
Any pretty much feedback questions or whatever. Like, yeah. So, Trevor asked if it can save an NFT.
Couldn't you represent the instructions to draw as like some data as part of an NFT?
Well, the final drawing can be an NFT, but I want to be like, this macro is essentially like a factory of drawings. So potentially it can use random, so it can draw something unique every time, like a fractal or some other piece. Because the storage, yeah.
Sorry, go ahead.
The data here can be potentially an NFT, but because it's produced from the factory, it's probably not a problem. In science, it has to be, I wanted it to be a contract instead of actual just the data itself. Then maybe not for this particular case.
Can I ask a question real quick? This is Trevor, by the way.
Yeah.
So in the thread of the NFT, would it be possible to replay all of the macros and basically, instead of having an off-chain storage solution for the NFT, you're actually just replaying those instructions so that the data is actually living within the contract. You're just adhering the spec of NFT.
All right. Yeah. But at the same time, like, it can live off chain as well. Well, like not off chain, but it can live in historical state, not in the latest state.
Yeah. So I don't know.
So
there's a project called Clovers.network that did this with basically it's similar to the CryptoKitties genetics, but all of the data, you know how NFT is basically an integer ownership. The data behind that was all on chain because it was so simple. You could replay the instructions.
All right. Yeah. Well, here you will also basically replay data from chain completely. So the macros, they will be stored on a contract. So you can store it. I guess if the macro is randomized, then yeah, it makes sense to actually like create NFTs. If it's reproducible every time, then it makes it also easy to just like make it a call instead of actually storing the final instructions of the drawing. But for now, I plan to just store the primitives that are given.
I have a side note question. Are we going to be doing multiple pitches today, or?
I think we can, yeah. If someone else wants to like pitch.
Yeah, I would like to nominate Evgeny Kapun because he has a great idea of implementing two-factor authentication on chain without protocol changes.
Cool. Yeah, let's do this.
Can you
do you
tell
have
everyone?
Do you want to use a whiteboard? It should be in the chat if you see it. If you don't, I can reshare. And then you can join.
I think I don't need a whiteboard. So my idea I know that currently in the wallet we have two-factor authentication, and it's important. It's an important security feature for those who are not using Ledger or something like that, because it meant that it's not enough to just get into the web wallet to sign transactions. You also need to get the second factor, which is so either phone or email. But there is a problem currently. If someone wants to use two-factor authentication, they need to deploy a special contract, and because of our storage staking, this locks approximately 35 near in the wallet, and 35 near is not a small amount, so it's a problem. But actually, I think that I can remove this requirement to stake more near by using some cryptography. So the idea is that currently what is this contract is doing, it actually implements the two-factor logic, like the user is issuing the transaction, it is not executed immediately, it's just stored, and then our server, which also has a key, when a transaction is confirmed, it issues another transaction using the server's key, and the smart contract checks that both the user and the server issued the same transaction, so not exactly the same, but that they ask the contract to do the same actions. So when both the user and the server confirm the same actions, the contract actually performs them. But with cryptography, it is possible to have a protocol where two parties, so in this case the user and the server, are creating a single signature. So instead of doing this in a smart contract, well, we like to do everything in smart contract, even drawing stuff. But sometimes there are things that are better done not in a smart contract. So the idea is to use this cryptographic protocol to generate one signature by both the user and the server. So the idea is that the user, the wallet running on the user's browser, will generate some data, send it to the server. The server will perform some additional cryptographic computation on this data, send back some other data to the user, and the user will do some final computation, and this will result in a signature. And in this process, both the user and the server will have to confirm, essentially, by continuing to do this, to confirm specific transaction. So it is two-factor authentication because the server alone cannot sign anything, and the user alone cannot sign anything. They need to act together. But then it's just one regular signature, so it can be submitted on chain with a transaction, and for the nodes, it will look like a regular signature, so nodes can verify, currently our nodes can verify regular signatures without the need for smart contracts. It's a built-in feature. So it will be a regular signature. We will not need to deploy a special smart contract. And in fact, we can maybe able even use it for example, for limited access keys as well. But I think the expected use case is to use it with full access keys. So because two-factor authentication is secure enough to let the signatures that it produces to authorize any action, so we can do it with, we'll probably implement it with full access keys, but in general, it's a cryptography. It doesn't care like what the signature is used for, so it can be used with anything. So that's the idea.
It's pretty good because it puts us further apart from Ethereum. Because right now it's really hard to pitch for people that we are cheaper than Ethereum and then say, well, you gotta look 35 near to, just to have a 2FA in your wallet. Kind of breaks our marketing. But that's it. I mean, I didn't expect that there was going to be this nifty trick. So, like, for those of you who, like, basically, it's we have a D25519 signature, and there it turns out to be cryptographic property that allows it to be signed instead of one step and two steps. And
Is it
Evgeny
only
just wants to exploit
n
it.
steps or like two steps of n steps?
Actually, it can be done by multiple parties. Like there are ways to do it if we want more than two. Like for example, we want multiple users to jointly create one signature. It is possible. It is easier with two parties because you can just do essentially one message from the user to the server and then one message from the server to the user, and that's enough. With multiple parties, you need more messages. And in fact, something similar is possible with ECDSA signatures, like those which are used in Ethereum, but it's much more complex. So ED25519 signatures are more suited for this. Actually, there are libraries that implement something like this for ECDSA signatures, but these libraries are complex, and it is, when implementing such a library, it is easier to make mistakes, and mistakes in cryptographic libraries are not good because they can make them insecure.
Can we use it with Ledger? Like, can we do the final signature step in Ledger?
I think we can't use this with Ledger because the step is not like creating just a signature in a regular fashion, and Ledger, I think, can only do like a regular signature creation process unless you can load some like custom programs. So I think Ledger can run custom like programs specific to a chain, like specific to the application specific, but it is not trivial to create this such a program. So with the code for creating regular signatures, you can't make it do this multi-party signatures, because it's, even though the result is the same, the process is different.
Can you do like 4 of 7 or
but
3 of 5 signatures?
What?
For the multi-party? For the multi-party signatures, can you do like a 3 of 5 people need to sign kind of scheme?
Yes. So this is called threshold signatures, when you don't need everyone in a group, but you need a subset of like some number of people, but not that any subset of this size. It is possible, but it is somewhat more complicated. So yes, it is possible to do some like complex stuff, but the thing is there's this specific case when there are two parties and both of them need to participate. It is simple. It is the simplest case of where it's actually multi-party signature.
And it's like a very obvious pain point in the current near experience.
Yes. So
yeah.
One thing that it is simple to implement, simpler than the general case, and the other is that it is actually immediately useful because we already have 2FA, but there is a problem. It needs to lock 35 near, and so if we plug it instead of the current implementation, we can remove this problem.
Just to double check my understanding of it, from the user perspective, it looks exactly the same. Other than that, they don't need the 35 near locked up in a smart contract.
Yes. Right? So ideally for the user, it should look exactly the same because they just press the button, then they confirm the actions, like they probably receive a text message and they check that everything is okay, and then they're entering the code. So that's what they're doing right now.
And they don't have to trust the server? Like, can someone else run the same like code on a server? And
they trust the server to the same extent as they trust it at the moment. So the server cannot sign anything unilaterally.
And it's like a kind of a thin service that other people can spin up to help decentralize the network, right? It's not.
Yes.
Like, what's the centralizing effect on the chain, I guess?
But of course, each instance is holding the key. So if a user's account is set up to trust a specific server, it won't work with other servers. And this is obvious because otherwise anyone would be able to run a server. If every account would trust every server, then of course there may be malicious servers which don't actually verify anything. So it's just as it is today.
Fantastic. How long does it take to implement something like this?
So I can try to implement the cryptographic part, but I think I would then want someone else to implement the front-end code to call into this cryptographic functions.
Makes sense. I mean, yeah, if you can build a demo, just like Rust or whatever binary that has the cryptography.
I think it will be JavaScript because it should be running in the wallet, which is in the browser. And I think it's then easier to have the server part in JavaScript as well, because I think we currently have contract helper, which is in JavaScript, and this part is naturally should be a part of contract helper, because contract helper is currently responsible for 2FA.
Awesome. Yeah, this is super cool. Anyone else wants to pitch? We still have half an hour.
There is a question in the chat for you, Evgeny. Is this similar to walletconnect.org?
What is walletconnect.org?
So it's more like a proxy than anything, but it seems like some of the interactions you were talking about could be very, very similar to what you were saying.
Well, from the website, it looks like they're just proxying the signing request from the apps to a wallet. So it's just mediating the communication.
Matt, we don't need to update new core because it just
We don't need to
cryptography
update
on
Neocore because, as I said, the result is a regular signature. So exactly like we are having right now. So Neocore can already verify such signatures.
So I know it can verify the signature, but how does it verify that it came from these keys?
So there are two keys, one from the user, one from the server, and they're added together to get a joint key. So there is a public key, but neither the user nor the server know the corresponding private key. So there is one public key, but two shares of a private key. And because of this, one share is not enough to create a signature. You need both. And there is a protocol to create a signature without actually exchanging those shares of the key, because if one of them had to send the share, then the other who received the share could reconstruct the entire key and just sign anything. But in this protocol, this doesn't happen. They actually exchange parts of a signature, but they can only use those parts to complete a signature on the specific transaction, not on anything.
That's really cool. Sorry, I may have missed this key piece of information, but are you talking about Shamir secret shares, or are you talking about Schnorr signatures? I just want to know which one.
ED25519 signatures is a variant of Schnorr signature. So any time you're creating ED25519 signature, you're creating a Schnorr signature because it's just it. It doesn't matter which way you're doing it.
So we can just aggregate the signatures.
But it's not aggregate signatures. So aggregate signatures is a kind of signature where you can do it non-interactively, like multiple people could independently create the signature shares, which can then be combined by anyone without any further interactions with those people who are making the signatures. But ED25519 doesn't have this property, so it cannot be used as an aggregate signature. But there is a so-called multi-party signature, so it's like aggregate signature, but it can be created interactively. So as I said, there is a user sending some data to the server, then the server is doing some computation and sending some data back to the user, and then the user is again doing some computation involving the private key. So it's not like anyone can combine those parts. You need some interaction. So it is less useful than aggregate signature. So for example, if we had aggregate signature on block approvals, then we could just have validators sending their signature, the individual signatures, and then any node could combine them into one aggregate signature. With ED25519, this is not possible because there is a step when, like one more step when, for which you also need those private keys. And for this reason, it is more difficult when there are multiple keys, because you need to send those parts of signatures back and forth between those key holders.
So just
I
to
think we
summarize,
got into technical discussion soon. Do you want to keep digging into this, or?
Well, does anyone else have any questions?
I think I have just like one kind of summarizing question. To implement this, we actually you don't even need a contract on the account, right? And sorry again if you've covered this, but you're really just talking about adding the public key of the joint signature to the account as a full access key, and then everything else is done client side.
Correct. So no need for a special smart contract, because it is just a regular key and the regular signature as long as the blockchain is concerned.
It's really cool.
Anyone else has ideas? Because I remembered something that popped up recently in the chat. So, you know, on the like Telegram channels, we always get questions like when Moon and when Coinbase and like stuff like this. So the idea came up where we can actually build a real predictor, like an 8-ball which you spin and it gives you the answer on chain. So you would send your question, include a small payment of 1 year to the blockchain. It will use our randomness to generate the answer for you. And later you can just use this answer whenever someone asks a similar question. You just point them and it's just saying like, it's happening, it's not happening. It's always going to be the same answer that is recorded on chain. So if anyone has a concern, you can always like say, hey, why don't you ask the prediction ball, or like magic ball, and it will give you the answer. And because it's like a smart contract, you can audit it to make sure that it's like doesn't fake the answers. You cannot edit the answer. So if you're lucky enough, the answer is gonna be good. So who wants to build it? It probably doesn't require like extra effort to build it.
Matt already has done a little bit of work using the VRF random deal. That this would be an awesome example of how to even access that.
Yeah, I have two things actually that I can share. I have like a slot machine contract and like a front end that's kind of funny, but it's not really pretty at all. And then the VRF, I have a little snippet of on Gist that basically takes the VRF and like puts it into like a super large, like, you know, U128. So these are just like little bits that you need if you're gonna do randomness. Like you'd need to have a U128, and then you just basically say for probability, you know, like it's less than this amount, or it's less than this bigger amount, or less than this even greater amount. But yeah, really cool. I like this 8-ball idea. Actually, you know, you could go so much further. Like you could have people people could make like it could be like a DAO, like people make proposals for answers, and then you can like you can bid up the probability of that answer showing up. So like people can like you could like stake your near like a token curated registry.
It sounds like you designed Flux or something. Except
Well,
you cannot create a new answer.
It's like a
resolution,
like a never-ending prediction market, right? So people come and they stake their near behind an answer being popular. And I mean, like you can always get your near back, but what you're doing is or we can make it token based. So we could just issue some banana token or something. You're good at that, right? So we give out like these banana tokens, and then people stake their tokens behind the answer that they want to show up more frequently.
Cool.
Before we stop, I'm not really a front end, but did we get a volunteer to help out Evgeny Kapun on his awesome idea?
Yeah, actually, I think it's so good. We have to bring it to the wallet team, and then basically, I think we just have to kind of diagram out a little bit about like how it works, and so everyone's on the same page. But I think that essentially what we can do here from the user's perspective is nothing should change for them, actually. Like it's very seamless to actually swap it out. But at some point we're gonna have to like blow away the multi-sig contract and replace it with this sort of signing scheme. And there's some flows that I've just haven't thought out yet that have to do with contract helper. And you know, it's great that it's client side, but like obviously if this is all happening now client side in the wallet and we don't have the on-chain storage of the request, we need to store everything like in the client. Like we need to sit, pause, have a pending request in local storage just in case the browser crashes, things like that. We need to figure out this whole flow. But it actually, it should be less.
I feel like you're talking about like a ticket now, but like here we are, Hack It Friday, baby. Like I thought, like the whole point was like let's like have fun, screw around, make front ends, all that jazz. Talking about like bring it to the team, making a ticket. I'm not sure that's really the spirit.
But he brought such a good idea that we should implement it. So
that's true. Okay.
That's true. Yeah. No. Mike makes a good point. I mean, it should just be like, to be honest, we should hack it. We should hack it out. Like, I mean, there should be an easy way to create like you don't need a contract or anything. We should just be able to make like a front end that basically is just like, you know, sign once, sign twice, and then you know, add joint signature key to my account, like a few different kind of flows there. It's very low hanging.
It feels like it should, yeah. It feels like the signing itself will be just like extremely simple. What you need is just on the wallet side to know that this is a multi-sig, and I think this is where the problem is. So, like when you recover your account from whatever thing, the wallet needs to know that this is a multi-sig signature. So it's not the signature that you can use just like by signing a transaction.
Like contract helper has that information. We know that, right? Like, so basically, if the only other key to sign was with contract helper, we could have basically that.
But it will also break the flow. Let's say you recovered your key, you cannot find the account for this key because indexer cannot give you the account for this key because you only have like a partial key. So you see one public key on the account and like you recovered with another public key. Or like private key.
That's actually a really good point. What if the other public keys, right, from the key pairs were were stored with some sort of so the user has no contract or some just no contract. But what if you add a key that has a receiver ID? It's just an access key as sort of like a marker of the recovery key. So you just add like
yeah, I think
or whatever.
We use this for the ledger right now to indicate that you have a ledger key. We have this magical access key with no methods or like some fake method on your own account, and that indicates that you have a ledger. So similarly, we can have this like partial key to indicate that it's part of multi-sig. And then when you recover account, you see this on your account. And
there's one other issue actually with the way that it's set up right now, multi-sig contract, the contract helper key only has permission to confirm. It does not have the permission to actually create a new request. So in the event of like a malicious attack, like if somebody compromised contract helper or someone with all of these other keys, they couldn't actually create requests for the user and fake the user into accepting something. But in this situation, I'm not sure if the keys can actually be differentiated, right?
No, well, they're two different keys. So
in this situation, the two keys, but they're similar in what they can do. So you need both keys to sign something, and with one key you can't sign something. And unlike with the current contract-based system, there are no requests like on chain. The only moment when something is published on chain is when the signature is completed. So any kind of request before the signature is completed are not on chain. They can be only in the UI somewhere.
But there's no way to restrict like which key signs first or anything like this. Like it just doesn't. It
doesn't matter. You still need both of them to interact. It doesn't really matter which of them signs first.
Right. I'm not sure if it matters, but that's just the way it currently works is like the user is the only one that should have the keys that can create a request, and contract helper can only confirm. So I'm not sure if this matters though, like in terms of
the current system, the request is actually published on chain before it's confirmed. But with this cryptographic system, the request is before the user can confirm anything. It is only shown to the user. So the UI could be designed to not accept arbitrary requests from the server. The only thing the UI will do is to let the user make a request and then ask a server to confirm it.
Yeah. Actually, I could see this working. Like basically, if it starts in the UI and then it has to be first signed by the user and then signed by the server. I get it. Yeah. Okay. So you can do the same thing. Okay. It's cool. It's really cool.
So when you do the 2FA, do you need to enter or like click the request? Like right now, how we do 2FA? So when you like send a request, then contract helper issued you, for example, an email or the message, right? Then do you need to click a link or you need to enter the number?
You go back to the UI and enter the code.
Yeah, so in this case, it's gonna be like the only latency there gonna be is because it's not on chain, so you don't need to wait for like a block to send the request then.
Yep. And I think Evgeny just answered my question. Like, you know, while you can't actually like with the cryptography you can't enforce like, you know, this comes before this, but with the client server model you can, like, because the server can only like the server code or whatever could have some kind of requirement that it will only sign with the second signature once it sees the first signature from the user, right? So the payload that's coming from the UI is already signed. So
it's not actually the first signature, like it's some kind of part of signature, but it doesn't matter really. So a server should only sign something once it's confirmed, like by the user entering a code, but it doesn't matter whether a user is signing the same thing or not, because until the user signs it as well, it will not be complete. So to get a complete signature, you need it to be signed by the user as well.
But you also need to indicate that the user sent the request. So how do you do this? Can you sign it with the, for example, this partial key?
Well, you can, but it's not needed, because if someone else sends the request, they can't complete the signature.
But they will send you to a file notification, which can be spammy. So the contract helper has to somehow confirm that it originates from the user as well.
Well, you can create a regular signature using the user's key just to authenticate the user to the contract helper.
Yeah, would be cool.
So it will not be a signature transaction, it will be just authentication. I think the wallet currently signs the current block height to authenticate itself. Actually, even if it signs something like empty string, some fixed string, it will also work. So the signature will be essentially kind of like a password.
yeah, I'm just running kind of scenarios. So for example, like wallet UI is compromised, right? Then spammy requests can be made from the UI, and then they go out through contract helper, but the user sees what the request is and in their email or SMS and says, I do not want to confirm that, so they don't confirm. But then the reverse is also true. If contract helper is compromised, we have to make sure, obviously, that if contract helper is compromised, they can email out and partially sign spammy requests and pretend that these requests are happening. But obviously, with no UI and with nothing happening on the local storage of the user, shouldn't happen. So there should definitely be just like a check. Like I mean, obviously, we should check if we upgrade this just to make sure that
this is how 2FA works right now as well. So if only one half is compromised, it cannot actually execute any actions.
Yeah, just double checking. Want to make sure. It's
regarding.
Sorry, I just say it's great to know that this was possible. It's obviously, when you look at this as sort of like the cryptographic solution, it should have been the solution from before. Like, I mean, there really is no need for this on-chain storage and this big complicated contract. It's a much more like elegant approach.
So now the question is regarding the recovery, right? Let's say contract helper is compromised or lost. You want to be able to recover your account. How
think
do we do this
currently,
right now?
I think currently, even if the user has 2FA, the keys that are used for recovery are full access keys, so they can sign anything without involving 2FA.
Only actually
So
only seed phrase keys are full access keys in the sense of recovery. So if you have set up an account and you have said, I want to use my email address for recovery and I want to use my phone for 2FA, you will only end up with 3 keys. There'll be like a method access key for 2FA to add and request and confirm. Add, request, and confirm. So that's for your email, for the local storage in the wallet, which you probably will lose. So you're only ending up with 2 keys. One, the email recovery key, which is not a full access key, and then contract helper key, which is confirming only. So we do have some scenarios where you're recovering and you require 2FA.
yeah, so it's 2 out of 3. It's not a full access key recovery, correct?
Yes.
Actually, if you have an email, then this email, it has a URL, and this URL currently includes, I think, just a seed phrase, but we can make it include additional information like a flag that this key from the seed phrase need to be used with 2FA. We can include this information in the URL.
Oh, God.
Wait, Matt, you said your email recovery key is not cannot create request?
No, your email. So yeah, sorry. A seed phrase recovery key is a full access key.
Okay.
An email, like because you're sending the seed phrase with the email link or the SMS link, and then if you enable 2FA, those 2 keys, those 2 types of recovery keys are not full access keys.
So once you enable 2FA, all keys are converted to a restricted access key towards the 2FA. But
if you have chosen email or SMS as your backup, yes.
oh, okay. So only seed phrase is full access key.
Yeah, and the reason, like the sort of thinking behind that is that a seed phrase is a seed phrase. Like, and you know, if you come from, you know, crypto and you copied the seed phrase on your device and you are, you know, reasonably sort of, you know, secure, then you can copy your own seed phrase. That's your key, right?
Yeah. But both keys that you would have, let's say email and phone number, that both of them can create a request.
They can create a request. Yes, they can create and confirm a request. So,
Cool.
yeah. And just because I shared like similar concerns to Evgeny Kapun about the fact that we're basically just sending these seed phrases through several other parties, because like you're going through SMS, you're going through email. It's like it's really actually terrible because those seed phrases are like touching the logs of several different companies.
Cool. Okay, we're out of time. Thanks for joining. It was a very interesting discussion today regarding this, and seems like it's going to be super useful if we implement it, because it's not only going to be faster, it also can be later used to enable some kind of weird 2FA regarding the ledger and maybe your device, and like, so yeah, supporting this natively in near API.js would be like another cool idea where you can join multiple keys on the near API.js. That will allow us to like implement more multi-sig solutions outside of this contract helper. So maybe I just want to have 2 keys, 3 keys, 5 keys, I don't know, with like multiple parties. So something like Gnosis style, like what it's called now, magic style, where you have like guardians to guard your key, so you can split it like this. So possibilities for this kind of cool. All right, thanks everyone. I'll stop recording and see you next time.